Hello, my name is Alberto Maya Romero, and today I'm going to solve this circuit using the mesh and super mesh analysis. First of all, what is a mesh? A mesh is basically a loop in a circuit, like this. And a super mesh is two or more meshes that are divided by a current source, like this one. So first, we're going to start doing the mesh analysis by this super mesh. As I told you, it's divided by a current source, so we know that this is going to be a super mesh. So let's start putting the current directions. This is going to be 2, I3, I1, and I4. Now that we have the current directions, we can put the polarity of the resistances, like this, and this. Okay, let's start with the first super mesh. We're going to start at this point. Minus 45 times the one entering the positive is I2, minus I3, then minus 54, the one entering is A1, minus I3, and this one plus 99 times I4. This is equal to 0. This is going to be our first equation. The second equation we need to do is the one of the current source, because it's the one that it's in between the super mesh. So it's this one over here. It's a 1/4 or 0.25. It's equal to the current entering the positive source. It's I4 minus I3. This is our second equation. Now we can do these separated meshes, this and this. Let's start with this. Minus 5 plus 30, 30 I2, plus 45 times I2 minus I3. This is our third equation. And last, this one. Let's start here. Plus 5 plus 54 times I1 minus I3. This is equal to 0. This is our third equation. Now we're going to put these equations in Wolfram so we can get the values of the i's. We have here our equations results in Wolfram. We have written them over here, so we can continue to get this Vx over here. We know this Vx is 45 times the current entering the positive sign, I2 minus I3. We can substitute now that we have our values. It's minus 705, minus and minus is plus 0.2286 times 45. This is equal to 7.114 volts. Now that we have this Vx, we need to get the power in this current source. The power equation is this one, the voltage times the current. So now we need to ask if we can use the passive sign convention. We can use it if the current on this loop is entering at the positive sign. In this case, it's doing, so we don't need to put the negative sign over here. We can use the equation like this. So first we need to get this voltage, doing a KVL in this mesh. So let's start over here. Let's call it PI, and 99 times I4. I4 is 7.3, and this is equal to 2.1087. It's equal to minus VA. Minus 2.10 it's VI. Now we can put this value here in the equation of power. Power is equal to minus 2.1087 times the current. The current is on 1/4 or 0.25. So let's get it over here really quick. And the power, it's equal to minus 0.5271 watts. The minus sign is because this current source is supplying power, not absorbing. That's all.